For more videos like this for Discrete 1, you can take a look at Sarai Studies. Link is in the description box below. Today I want to talk about set notations. In the last video, we introduced what sets are, and we denoted a set using the roster notation. So we said that some set A could be equal to, and we just listed out the elements of a set A, 1, 2, 3, 4. That's what we call roster notation. But there's another notation called set builder notation, where you could say that set A is equal to, and then the general form, note that every single thing in here we call an element of set A. So all of these are elements. You can think of them as X. So for every X, for every element that we are considering, so in the universe of things that we care about, I'm just going to write this as normal U. So we're considering every X that we care about such that this condition P of X is satisfied. So P of X is just going to be a property of that X. So to put it into context, I could describe this set using set builder notation as saying that A is equal to all X in the set of integers that are positive, so all positive integers such that the X satisfies a condition that it has to be less than or equal to 4. So this is another way to describe this set right here. So P of X is equal to X is less than or equal to 4. That is the condition, the property that X has to satisfy. Now let's practice. Here we have this set of all natural numbers less than 10. So I could say that the set A is equal to natural numbers start at 1, 2, 3, 4, and go on forever. So I'm just going to go up until 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it because it doesn't include 10. With set builder notation, I can say that set A is equal to all X in the set of natural numbers such that X satisfies the condition that it has to be less than 10. What about the set of all positive integers less than 5? Well, I can say that this set is equal to, remember that integers is a set of all integers, which is equal to negative integers, 0, and then positive integers. We're talking about positive integers, so we ignore everything, and then we start from here and go to infinity. So it starts at 1, and we want less than 5. So it's 1, 2, 3, 4, and we don't include 5. With set builder notation, the set could be described as all X that are in the set of all integers, not just integers, positive integers, so you add a little plus sign, such that X satisfies the condition that it has to be less than 5. What about the set of all non-negative integers less than 5? So you're dealing with integers. Integers include negative numbers, 0, and positive numbers. Non-negative means you're not dealing with the negative numbers, and that's it. So it means you include 0 and positive numbers, because remember, 0 is neither negative or positive. It's just 0. So that's why there's a difference between positive and non-negative. It has all to do with a 0. So with integers, not including negative numbers, we start at 0, so our set can be equal to 0, and then all the numbers up until 4 because we don't include 5. So 1, 2, 3, 4. In set builder notation, we can say that A is equal to all X inside the set of all integers greater than or equal to 0, such that X satisfies a property that has to be less than 5. And if it said less than or equal to 5, then we would have 5 here, and we would have an equal sign there. Now, what if we want to describe the set of all natural numbers? What would it look like? Well, I know that natural numbers start at 1, 2, 3, 4, 5, 6, and it says all of them. And there's infinite amount of them. So there's no way that I could actually list out all natural numbers. So you would think, oh, I can't use roster notation, but something that we can do is just put a ... if the pattern is obvious. But realistically, you want to use set builder notation. So you would say that your set is equal to all X in the universe. So out of all of the elements that we could ever have in the universe of things that we care about, so in this case, the universe may be all numbers, those elements, those X, have to be natural numbers. They have to be an element of the set of natural numbers. So you want to use roster notation when you can literally list out every single possible thing in the set, and you want to use set builder notation when you really can't do that. So you can simply just describe the set like so, when there's really infinite amount of values. And finally, the third way to describe a set is by using a Venn diagram. So if I have a set A and it contains elements 1, 2, 3, and 4, then I can represent set A with a circle and space. I can label it A, and the stuff that goes inside the circle are the elements of set A, so that will be 1, 2, 3, and 4. If I need to represent this using a Venn diagram, well, it's going to be a circle and space. Let's say that this is set B, so I'm going to call it B, and we're looking at positive integers, so we know that starts at 1, not 0, and then we're going up until 5, not including 5, so less than 5 means we're not including 5, so we start at 1 and go all the way to 4, so that would be 1, 1, 2, 3, and 4. So let's say that in the same universe I have these two sets. Set B contains the elements 1 and 2. So the idea is I can circle 1 and 2 and label this set B. And so this would be the universe of all numbers. You can do the same thing here, have a U. So it's like the universe of all numbers, this is set B. And the universe of all numbers, this is set B and this is set A. Now this is our transition to the next video, because notice how we have two sets and these two sets are related to each other. The relationship is that this set is smaller than this set. So we call this a subset, sub for smaller. So B is a subset of A. So one set being a subset of another is one of the three relationships between sets that we can have, which we will cover in the next video. We'll see you then.